Okay, we're going to go ahead and start with Chapter 10, which deals with using fundamental identities. We're going to take some of the identities that we looked at in Chapter 9 and then just do some more complicated problems involving verifying identities. So that's what we'll do in the first video. And in the second video for this section, we'll take a look at how we can factor and simplify expressions involving trig using various trigonometric identities. Okay, so the trigonometric identities that get used most frequently in both this section and in the next section are the Pythagorean identities, which there are three of them. The first one that you needed to memorize was sine squared plus cosine squared is equal to 1. Once you have that identity, you can come up with the other two very easily. To get the next set of identities, you can divide both sides of your equation by cosine squared. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. And then to get the third one, you can take both sides of that first identity and divide everything by sine squared. So sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared, and 1 over sine squared is cosecant squared. Okay, so with that said, let's go ahead and take a look at the first example. So the directions ask us to verify the identity, and we have the sine of theta over 1 plus the cosine of theta plus the cosine of theta over the sine of theta is equal to the cosecant of angle theta. So you guys remember back in the previous chapter when I taught you how to verify identities, I said that we wanted to start with the more complicated side of the equation, which in this case is the left-hand side, and we want to use algebra and identities to take that left-hand side of the equation and make it look like the right-hand side. So this is kind of the process that I use with identities. I want to take what we have on the right-hand side, so the expression that we're trying to show or verify, and I want to use that to help me like guide my path on the left-hand side. So when I look at the right-hand side cosecant, there are two things that I see. Number one is that cosecant I can rewrite as 1 over sine. Okay, and secondly, because I can write cosecant as 1 over sine, which is a single fraction, that probably tells me that I need to take the left-hand side and combine it into a single fraction as well. Okay, so that's going to kind of guide me on my journey to verify the identity. So if I want to take the left-hand side and combine it into a single fraction, I'm going to need a common denominator to do so. So the common denominator for the left-hand side is going to be 1 plus the cosine of theta times the sine of theta. For me to give the first fraction that denominator, I have to multiply the top and bottom by sine. So when I multiply on top by sine, sine times sine is sine squared. Okay, for me to give the second fraction that denominator, I have to multiply the numerator and denominator by 1 plus cosine. Okay, so we just want to go through and simplify the numerator now. So that numerator is going to be sine squared. I'm going to distribute cosine across those next two terms, but in doing so, I'm going to switch the order. Okay, so I'm going to multiply cosine times cosine first, which makes cosine squared, plus cosine times 1, which is cosine. And then we're going to divide that by our denominator, which is 1 plus the cosine of theta times the sine of theta. Okay, well, when we look at that numerator, sine squared plus cosine squared, we know using the Pythagorean identity that that's going to be equal to 1. So I can now rewrite that numerator as 1 plus the cosine of theta over 1 plus the cosine of theta times the sine of theta, and then we can cancel that factor of 1 plus cosine on top with the factor of 1 plus cosine on bottom, which makes 1 over the sine of theta, which we can rewrite as the cosecant of theta. All right, so we've gone and verified that first identity. Okay, let's do the same thing with the second one. So for the second one, again, our more complicated expression is the one on the left-hand side. So that's the one that we're going to start with. And again, I want to take what I'm trying to verify. So the right-hand side, I'm going to use that to help guide me on the left-hand side. So the right-hand side is 2 times the secant of theta, which again, secant we can rewrite as 1 over cosine. So that's going to become 2 over cosine, which tells me because that is a single fraction, I'm going to want to take the left-hand side and combine it into a single fraction as well. Okay, so if I want to combine the left-hand side into a single fraction, we need a common denominator, which is going to be cosine times 1 minus sine. So to give the first fraction that denominator, I'm going to multiply the top and bottom by 1 minus sine. So that's going to become 1 minus sine quantity squared. To give the second fraction that common denominator, I need to multiply the top and bottom by cosine, which cosine times cosine is cosine squared. And now I want to simplify that numerator. So when I FOIL out 1 minus sine quantity squared, that's going to be 1 minus 2 times the sine of theta plus sine squared of theta plus cosine squared of theta all over cosine times 1 minus the sine of theta. And again, just like with the previous example, we have that expression sine squared plus cosine squared, which we know is equal to 1. So when I combine like terms in the numerator, we get 2 minus 2 times the sine of theta over the cosine of theta times 1 minus the sine of theta. And then I can factor a 2 out of that numerator. So that's going to be 2 times 1 minus the sine of theta over the cosine of theta times 1 minus the sine of theta. And we can cancel those factors, which gives me 2 over the cosine of theta, which simplifies to 2 times the secant of theta. So we went through using algebra and identities to show that the left-hand side becomes the right-hand side of that equation. So we verified that identity. Okay, under problem 3. So here we have the secant of theta raised to the 4th power minus secant squared is equal to the tangent of theta to the 4th power plus tangent squared. For this problem in particular, I don't think one side of the expression is any more complicated than the other. So you can start with the left-hand side or you can start with the right-hand side here. I'm just going to go ahead and start with the right-hand side because the previous 2 examples, we started with the left-hand side. So I'm going to show you that we can verify the identity starting with the right-hand side. Okay, so my goal is to take the expression involving tangent only and get it written involving secant only. Okay, well, the only thing I can really do to manipulate the expression on the right-hand side is factor out tangent squared. And when I do so, that gives me tangent squared times tangent squared plus 1. Okay, so if I want to get this expression written in terms of secant only, well, we can go to the middle identity. Tangent squared plus 1 is equal to secant squared. So we can use that. And then if I take that middle identity and subtract 1 on both sides, we can also say that tangent squared is equal to secant squared minus 1. Okay, so with that said, we can say that tangent squared is equal to secant squared minus 1. And then that second factor, tangent squared plus 1, we can say is equal to secant squared. All right, so all I need to do now to transform this into the left-hand side is distribute secant squared across both terms, which would make the secant of theta to the 4th power minus secant squared of theta. And we verified that identity. And you could have also done this the other way. So if you wanted to take the left-hand side and show that it was equal to the right-hand side, all you would do is take the identity that we verified and work it through in the opposite order. So the bottom line would be your first step, the second from the bottom would be your second step, the third from the bottom would be your third step, and then the top line, that would be your final step. Okay, to verify the identity going in the other direction. All right, last one. For verifying identities, number 4, we have 1 minus cosine squared over 1 plus the sine of theta is equal to the sine of theta. Okay, so again, our more complicated expression is the one on the left-hand side. So I'm going to start with that. And show that that gives me the right-hand side. Okay, so for me, the first thing that popped in my head to simplify this was when I look at the numerator of the fraction, I can rewrite the numerator of the fraction using the Pythagorean identity. So cosine squared is going to be 1 minus the sine squared of theta. When I do that, that numerator of the fraction now is the difference of 2 squares. So I can factor that numerator to be 1 plus the sine of theta times 1 minus the sine of theta over 1 plus the sine of theta. Once I've done that, now I can cancel the factor of 1 plus the sine of theta in both the numerator and denominator. So this expression then becomes 1 minus the quantity 1 minus the sine of theta. When I distribute that factor of -1 across both terms, this becomes 1 minus 1 plus the sine of theta. And then when I combine the constant terms, that just gives us the sine of angle theta. Okay, so we verified that identity as well. And again, if you come up with something different, as long as it's trigonometrically and algebraically sound, that's okay. For a lot of these identities, there's more than one way to approach them. Okay, so in video 2, we'll take a look at factoring some expressions, some trigonometric expressions, and then we'll look at how we can simplify trigonometric expressions as well.